In this presentation, we have to discuss about multiplication table of the water molecule. Water molecule belongs to C2V type. The symmetry operation of water molecule consists of four operations. E, the identity operation. C2, rotation through 180 degree. Sigma yz and sigma xz are reflections through perpendicular and parallel planes. To construct the multiplication table, we have to write the symmetrical operations in terms of row and column. Here EC2, sigma yz and sigma xz are presented in terms of row and column. Now we have to make the multiplication. E, the identity element. Multiplication of any element with E will provide the same element, so that we have written all the elements in the row as such: E into E, E into C2, C2, E into sigma yz, sigma yz, E into sigma xz, sigma xz. Then C2 into E is C2. The product of any element, the identity element, is the same element, so that C2 into E is our C2. Now we should calculate the values of C2 into C2, C2 into sigma yz, C2 into sigma xz. First we should find out the value of C2 into C2. Before that, we should know the symmetry operations involved in the water molecule. If we carry out certain operation, even after the completion of the operation, if the body may retain its original position, such operation is called as symmetry operation. It is identity operation. Identity operation means no operation or 360 degree rotation. Do nothing is called identity operation. This is water molecule, which consists of central oxygen and two hydrogen atoms are placed at equal distances from the central oxygen. If you provide no rotation or no operation, we can get the same structure. Here the center dot indicates the front face of oxygen. This is the identity operation. Then the second operation is rotation. Here 180 degree rotation is made through the z-axis. If you perform 180 degree rotation through the z-axis, the two hydrogen atoms are interchanging their positions. H1 and H2 are changed as H2 and H1. Furthermore, the face of the oxygen is also changed. Here the front face is present, but here after completion of the rotation, we are seeing the back face. This is C2 operation. Anyway, after completion of the C2 operation, we have had the original structure of water molecule. H2O is arrived. Then the third operation is reflection through the vertical plane. So this is water molecule, x-axis, this is y-axis, this is z-axis. This is our vertical plane. The water molecule has two planes of reflection. One is vertical plane and another one is horizontal plane or molecular plane. If you make reflection through this plane, we can get the same structure. Here, the reflection is performed through this YZ plane. This is Z plane, this is Y. Vertical plane is constructed with the help of the axis Y and Z. After completion of this reflection process, the two hydrogen atoms are interchanging their position. H1 and H2 are changed as H2 and H1. However, there is no change in the phase of the oxygen. The same phase is harvested. After completion of this reflection, we can get the actual structure of water molecule. H2O is arrived. What will be the positions of these two hydrogen atoms? And the fourth operation is reflection through horizontal plane. If reflection is made through the horizontal plane, we can get the actual structure of water molecule. So that this operation is also called as symmetry operation. In the horizontal plane, if you perform a reflection, there is no change in the positions of these two hydrogen atoms. These two hydrogen atoms are present as such. However, the phase of the oxygen is changed. Here we are seeing the front face. After completion of the operation, we are seeing the back face. Anyway, after completion of this reflection operation through the horizontal plane, that is XZ plane, we can get the actual structure of water molecule. This horizontal plane is also called as the molecular plane. So by the way of carrying out all these four operations, we can get the actual structure of water molecule. So these operations are called symmetry operations of water molecule. They will constitute a group called as point group. Now, we would like to calculate the multiplication of C2. For that, say this is actual water molecule. Allow this water molecule for C2 operation, which means that this is subjected for 180-degree rotation through this z-axis. Once the 180-degree rotation is made, these two hydrogen atoms are interchanging their position and the phase of the oxygen is also changed. This is C2 operation. Then once again allow this molecule to C2 operation, that is further 180-degree rotation. If you perform further 180-degree rotation, once again these two hydrogen atoms are interchanging their position, so you can get this structure H1 and H2. Then the phase of the oxygen is also changed. Finally, we have harvested the front face of the oxygen. This is equal to our identity operation. See this identity operation is providing the same structure, that is the phase of the oxygen is also unchanged. See, in the C2 into C2 operation, we have harvested the identity element. Say this is C2 into C2. Once C2 is performed, we can get this structure, and the repetition of C2 will provide the identity element. So C2 into C2 is equal to E. Now we have to write the identity element here. C2 into C2 is our E identity element. Now next C2 into sigma yz. See, this is C2 into sigma yz operation. You know that C2 operation interchanges the position of hydrogen atoms as well as the phase of the oxygen. Then the C2 should be subjected for sigma yz. This is a reflection through vertical plane. If you perform reflection through vertical plane, the two hydrogen atoms are interchanging their positions. However, there is no change in the phase of the oxygen. So H1 and H2. Now compare the arrived molecule with our earlier operations. See, H1, H2 H1 H2 and back face is our sigma XZ. Therefore, a water molecule is initially subject for C2, then the arrived molecule is once again allowed for sigma YZ operation. As a result of this, the finally obtained molecule is in sigma XZ form. So C2 into sigma YZ is our sigma XZ. See, instead of this C2 into sigma YZ, we have to put sigma XZ. This is our sigma XZ. Next operation is C2 into sigma XZ. See here, C2 into sigma XZ. Then as usual, C2 operation interchanges the position of hydrogen atoms as well as the phase of the oxygen. Then the arrived C2 is subjected for sigma XZ. Sigma XZ means reflection through the molecular plane, that is horizontal plane. If you carry out the operation through the horizontal plane, that is reflection operation, there is no change in the position of the hydrogen atoms. However, the phase of the oxygen is changed. So this is changed as H2, H1. As usual, H2 and H1 are arrived. Then the back phase is changed as front phase. Now compare this newly arrived one with our earlier individual operations. See this H2 and H1 with the front face. H2 and H1 with the front face is our sigma YZ operation. Actual water molecule is subjected for sigma YZ, we can harvest this. That is H2, H1 with the front face of oxygen. So this is our sigma YZ. C2 into sigma XZ is our sigma YZ. So here we have to put sigma YZ. Then sigma Y into C2. These two are commuting. C2 into sigma YZ. See that? C2 into sigma YZ equal to sigma YZ into C2. These two are subjected for commutation. Therefore, automatically we can fill this table. Sigma YZ into E equal to sigma YZ. Sigma YZ into C2 is the value of C2 into sigma YZ. That is sigma XZ. We can fill it out automatically. Sigma XZ. Then sigma YZ into sigma YZ is our identity element E. This is identity element E. Then sigma YZ into sigma XZ is what we have to find out. Sigma YZ into sigma XZ operation. Now we come to our final operation. This is our sigma YZ into sigma XZ. So this is our hydrogen molecule. We have to perform sigma YZ operation, which means that the reflection through the vertical plane. If you perform the reflection through vertical plane, these two hydrogen atoms are interchanging their positions. H1 and H2 are changed as H2 and H1. However, there is no change in the phase of the oxygen. Actual phase is obtained. Then further allow this molecule for sigma XZ operation, which means that the reflection through the horizontal plane. If you do that operation, these two hydrogen atoms are maintained their positions as such. However, the phase of the oxygen is changed. So the newly arrived structure is our C2. So sigma YZ into sigma XZ is our C2. See this C2 operation, that is rotating through 180 degree. is performed directly to a water molecule, we can get the displacement of two hydrogen atoms with the change in phase of oxygen. Therefore, this is our C2. Sigma yz into sigma xz is our C2 operation. Write down here C2. This is C2. Then sigma xz into E is sigma xz. Sigma xz into C2 is equal to C2 into sigma xz. So the value is sigma yz. This is our sigma yz. Then sigma xz into sigma yz is sigma yz into sigma xz. That value is our C2 because they are subject for commutation. Sigma y xz into sigma xz is our E, identity element. This is E. If you want to verify this, sigma xz and sigma xz, see the sigma xz operation. This is sigma xz. If you allow once again the sigma xz operation, this is actual water molecule. After performing sigma xz operation, you had this structure, which means that these two hydrogen atoms are presented in the actual positions, but the phase of the oxygen around is changed. Once again, if you allow sigma xz operation, we may maintain the same structure H1, H2 and the front face. That is our identity element. Therefore, we can write sigma xz into sigma xz is our identity element. So this is a multiplication table of water molecule. This belongs to C2V type. Here one rotation and two reflections are present. In this way, we have constructed the multiplication table of water molecule. Then these are all the points we have to keep in our memory. C2 into sigma yz is equal to sigma yz into C2. That is commutation property. Then E dot E is E, C2 into C2E, sigma yz into sigma yz is E, sigma xz into sigma xz is also E. If you go through this multiplication table, all the rows and columns are having all the elements. No repetition is present. That's all about the multiplication table of water molecule.